Alright, so now we're simplifying, which means trying to find perfect squares that we can pull out of the square root. So again, I'm thinking 96. Do I know perfect squares that go into 96? Again, let's write the perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and so on. So again, like, where do I even start to look, right? I'm thinking numbers bigger than 96 won't go into 96 evenly. I don't have 96 in the list. 81 seems a little big, so I'm trying to figure out things that are like half as big at least, and half of 96 is 48. So 40 now. So what about 36? Does 36 go in? I think not. Nope, 2 2/3, so not 36. 25, it doesn't end at 5. This seems like something 5 base won't go in. What about 16? That goes in 6 times. So this is square root of 16 times square root of 6, which is just 4, because square root of 16 is 4, times the square root of 6. So that's simplified. 1200, again, I see 100, and I think, okay, that's at least 100 goes in whenever I see something with 2 zeros at the end. And 12 could be broken down further into square root of 4 times square root of 3, and I still have my square root of 100. Square root of 4 is 2, square root of 3 is square root of 3, square root of 100 is 10, and we rewrite this now with all the integers outside of the square root in front and multiply together. So 2 times 10, 20, square root of 3, that is your solution. Okay, so simplifying could require multiple steps, multiple square roots to be pulled out. Right? In fact, if I had thought ahead, I could have probably pulled out 400 from there, which is just 20 times 20. So square root of 400 times square root of 3, if I saw that. If I didn't, I just have to keep repeating the process until I find them all. And you can do that. A lot of people work from the bottom up, but it takes a lot more turns. So let me show you an example of that. So if I were to look at the bottom, right, 1 goes in obviously, but that doesn't help me. 4. Does 4 go into 648? Yeah, it goes in 162 times. So I end up with square root of 4 times square root of 162. Now, does anything go into 162? I wonder if 4 doesn't seem to go in. What about 9? 18 times. So now I'm square root of 4, square root of 9, square root of 18, which is the same as square root of 4, square root of 9, and 18 breaks down to square root of 9, square root of 2. So now I gotta do some compilation. This is 2, 3, 3. So 2 times 3 times 3 times square root of 2, which can just be rewritten as 18 root 2. And so that took a bunch of steps, right? And maybe the smarter choice would have been to try to pull out, I don't know, like an 81, right? If I tried to divide 81 into 648, I'd have found it went 8 times. So square root of 81 times square root of 8 would have been at least a little easier, because then I could have broken this down to square root of 4, square root of 2, and I would have ended up with 9 times 2 root 2. Much fewer steps. But it's up to you. You just need to remember you need to keep looking for perfect squares until you get to numbers where you know there are no factors in them that are perfect squares. Now, what happens when we start adding variables into the equation? Well, it's no different, but we need to sort of treat it as the numbers and the variables. So let's look for perfect squares. Anything with an even exponent on a variable, that's a perfect square. So I know this is x squared out front, right? Because x squared times x squared is x to the 4th. or if you'd like, I can break that down just to square root of x squared times square root of x squared times square root of y squared, square root of y squared, square root of y squared. That's 6 of the y's, and square root of y. And also I have this 72, which turns out to be square root of 36, square root of 2. So these are all multiplied together. So now square root of x squared is just x times y squared is y squared is y squared is y. Square root of y stays square root of y. 36 turns to 6, and square root of 2 turns into 2. And now I need to rewrite this in some more sensible way. So I'm going to put the coefficient out in front. I'll then put my x's together, x squared, my y's together, y cubed, and I'm left with square root of 2 times square root of y, which is just the square root of 2y. So some of this is just about keeping your wits about you, looking for perfect squares, and then consolidating information together. All right, this last one, 160 breaks down into 16, square root of 16, square root of 10. This is the square root of x to the 22. Instead of breaking it all apart in x squares, I'm just going to think of this as x to the 11th times x to the 11th. I'm still left with one x there, and then I have y to the 4th, which I just know is y squared squared. So now the 16 breaks down to 4 root 10 times x to the 11th square root of x times y squared. And now getting all the things out of the square root together, because I don't think I can pull out anything from 10. Right, 2 and 5, yeah, those don't have perfect squares. So this is 4x to the 11th y squared square root of 10x. So to simplify, you need to find all the perfect squares and take them out of the square root and then consolidate them in front of the square root and consolidate all the items that are still inside the square root. Hope that helped.